I know you'll be wondering, most times when you see a lot of solar panels, probably on the roof of a house or maybe laid in some platforms, you'll be wondering how they are connected, because these are single panels interconnected and arranged to generate energy, and you'll be wondering how this is done. So in this class, I'll be showing you what we call the solar panel stringing. The solar panel stringing simply means the connection of several solar panels to generate a particular amount of voltage and a particular amount of amperage. Okay, now we know that several panels are arranged with individual voltage and individual amperage. So you see, this is a single solar panel and it has 30 volts. This one has and 8 amp. So the same, is similar with several of these panels. And we have 4 different panels with with their different terminals, how they will be connected to generate a single output energy, and how it will be connected to our equipment. So because we know we cannot run, if we have 4 panels, we cannot run 4 different cables to 4 different panels. So how do we connect these things to just give us a common energy output? So we will be talking about the stringing, and there are several types of panel stringing. So for this class, we'll be talking on this, which is the parallel stringing. Now, for solar panel stringing, we have 2 major types of stringing, which is called the parallel or the series connection. So when connections are done on solar panels, it is either done in parallel or is done in series. Now, sometimes we also have the combination of both parallel and series just to generate energy. So for this class now, I'll be showing you how it is done in parallel. Remember, in basic electrical and physics, we know that when an electric circuit is connected in parallel, the amperage is increasing while the voltage remains constant. So for this place, we will be connecting a parallel connection, and a parallel connection is saying all the positive will go to positive and all the negative will go to negative. So let me show you with this diagram. So we have the positive cable indicating the red cable. We have to link it with this positive, and we go further to this positive. That's the second panel. We link it to the second panel. We go to the third panel, we link the positive. We go to the fourth panel, we also link the positive. So we have a single positive that is probably going to our inverter if it is a hybrid inverter, or probably the charge controller if we have an independent charge controller. Now we have the negative also. So this is the negative terminal of this panel, the negative terminal of this panel. So we also have the cable will go and also will connect this to this. We also have this, which is the third panel, connected to the common negative, and finally the last connected. So we have a common cable. We have a common cable conveying the positive, which is on the red cable, and also have a common cable conveying the negative, which is on the black cable. So remember, we earlier said that if we are to connect this in parallel, the amperage increase. So we have the amperage to be, we have how many panels? 1, 2, 3, 4. So 8 times 4. 8 times 4 is 32. So we have 32 amps generated while the voltage is constant. So we have the voltage to be 30. So this system has 30 volts, 32 ampere. We'll still link, when you link this, you have your energy running. So this is exactly how solar panels are connected. So you see us having 100 panel, 20 panel, 15 panel on the roof, but at the end of the day, one cable is brought out of the whole thing. So this is how you see how connected this 4 in parallel, you can do 10 in parallel, you can do 6 in parallel, just maintaining the same principles we used. Thank you.